Okay, section 2.4, example 5. It's two more of these pathway problems. So we're going to determine the number of routes there are to get from point A to point B. And we're restricting it by saying you can only travel south or east. So in example A here, we want to break up, when we have these two squares together, we want to break them up into two different routes. So I'm going to put a dot there and we're going to call it C. Okay, so we want to look at first how many ways to get from A to C. And like I said in the last video, these are easier now if you just go around the edges. So there's always going to be three easts, right? East, 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 and two souths. So from A to C, we have 5 moves to make. And there are 3 easts, and there are 2 souths. Which gives us 10 routes from A to C. Now we want to go the next set of routes, so that's going to be from C to B. I can do this in a different color, and again I'm just going to do the ones that go around the outside because that's just the easiest one to mark off. It doesn't really matter which route you pick. So that's east, 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 south, 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 which gives us, so that's 1, 2, 3, 4, 5, 6, 7 moves. So from C to B is 7 moves. 4 of them are easts, 3 of them are souths, and that gives us 35 routes. And then think of this back to, or think all the way back to the difference between and or. We have to do both A to C and C to B, not either or. You have to do both. So we want to multiply then our two sets together to get to AB, which is going to be 10 routes times 35 routes is 350 routes total. So the strategy here for these multiple squares, in examples like A, we'll do B separately in another video. But the strategy here is to separate, and multiply, or treat it like an and type of problem where we're doing one set of routes and the other route.